All right. Good afternoon, everyone, and thanks for coming. I thought what we'll do is we'll talk about data manipulation using R. It's going to be an interactive session, as in we can have Q&A as we go along. And I also have RStudio with the code loaded here, so that I would like to show you not just the slides, but also some maybe live interaction as we do this. We'll try to do some data manipulation here. All of these slides I've made available for you in this link. So if you just goo.gl and then the shorthand link, capital T, capital X, small e, capital 1, small z, and s. So if you're able to find it, then you can follow along. Otherwise, you can get it later. Before we jump in, I just want to get a feel for the group here. How many of you have already been using R for a little bit at least? Okay, good number of you. People who have not used R at all? All right, so for those of you who have used it, a little bit of it, I want to just make sure I don't go through fast. And anyone here familiar with or tried using dplyr? Okay, so maybe because there's so few of us, I'll spend a little more time on, say, basic or regular data manipulation, and I'll spend a little bit of time on this new package that has come about called dplyr, which makes data manipulation using R really, really easy. So again, I probably will assume certain things that you may know. If you don't, just stop me. That way we can make it a more useful session for you. It's not just for me to race through. I have maybe about 25 or 30 slides here, not counting the title slides and so on. So I thought what we could do for this session, 45 minutes or so, we'll talk about the basics of data manipulation. What do we mean by it, right? And some reserved words in R. Let's understand those because they keep showing up. People assume we know what we're talking about. Then data quality means so many different things to so many people. So what do we mean here by data quality, and why is it so important, and how should we clean up the data that we get? If we get through that, and if we get through subsetting of data, I think we are good for today. I would have achieved a little bit of what I wanted to achieve. If we have more time, like I said, I would like to dive deeper into dplyr. In my slides, probably half the lecture or half this presentation is on dplyr, but it depends on your appetite whether we are able to get through or not. First, a little bit of note. You should know that R actually comes in already bundled with quite a number of data sets. So it's not as if we have to go get it from somewhere. It is available. Also, people in general, for those of you who are new to R comes with this base R and a few very basic packages that sort of come along when you download R. And those of you who have not used R, you should do two things when you go home. For your system, whether it's a PC or a Mac or Linux, whatever your operating system may be, make sure that you download R. And I would also strongly recommend that you also download RStudio, which has sort of become the de facto way of using R these days. It's almost become hand in hand, even though technically you don't need RStudio. You can just use R without it. R comes with its own called RGUI, but it's becoming less and less popular. Pretty much everybody, including the talk that Joe gave earlier on here, uses RStudio. I will use RStudio, and everybody who uses R starts to use RStudio. So make sure you get both of those. But first download R, then you download RStudio. That way you know where your R is available, and then you are ready to go right after that. When you do that, you will also find that you have a lot of packages that already came bundled with R. So for example, to find out what you have, the command is just called data. Just as a way of testing it out, let me see if I can go to this is my RStudio window, and let me see if I can get a new. Fortunately, I can return back and type, but so the command is just called data there. If you can see it, you just hit that command, and it pulls up all the data sets that my laptop has access to, that it's pointing to. There were several things that I must have been working on, and then if you keep scrolling through here, there are any package that I may have downloaded that already have, for example, air passengers to BOD, CO2 is carbon dioxide data. So all of these R was able to find out as being available in my laptop. Obviously, I don't even know many of these, and I didn't download those. As I download packages, they just come along with them. So I just wanted you to know that for you to start testing out, so much available here. And the dplyr package comes with this NASA set, ggplot2, which we will look at today for one data set that I want to spend on. It's called movies. There it is. It has all the IMDb movies and ratings up to the year 2005 and so on. There are many, many data packages that are available. So I just wanted to sort of tell you that it is available there, and we could use that. Very common examples, if you start looking at R code anywhere, if you go to GitHub or you get a book on R, people will talk about empty cars, iris, I-R-I-S, quakes, faithful, and air quality. Women is also a data set. Just a note about this data set called Iris. This data set has measurements on 150 flowers. Okay, so this goes back to the stellar statistician Fisher, after whom F-test and many other things are named, and he was instrumental in a lot of advanced statistics. But what he did is he collected 50 flowers of 3 species, and then he measured their petal and their sepal and a lot of different stats on them. And this data set is used not only in R, but if you use Python or in many data programming or data analysis packages these days use Iris also. So we could look at that. And like I said, movies are also there. You could start looking at all of this. So again, I want to tell people that since these things come, you can sort of play with them. They are somewhere deeper in your laptop, so you don't have to worry about it. You can delete, you can do all of that. But when you bring up R again, they'll come back, so you don't have to worry about it. Feel free to experiment. That's the only way to learn data manipulation.
Yeah. You are recommending we look at package dplyr.
Yes.
If you want to know what a package does, what is the simplest way to check it?
What does
package do?
Yeah. That's let me see if I can put that. Okay. His question was, how do I know what a package does? It's a kind of a difficult question. I mean, you have to know about packages to know what they do, but you can always go to a search engine. There are places where packages are announced, but if anything else, I would recommend that you go to Google and type something like Introduction to dplyr or dplyr Basics. I should also mention that CRAN, C-R-A-N, which again Joe also talked about. CRAN is sort of the de facto repository of all good R packages sort of end up there. 6,000 of them now. It used to be much fewer before, but in the last few years it has rapidly grown. Now what happens in CRAN, when you submit any package to CRAN, along with it they'll ask you to give a lot of help files. They don't accept a package unless it has this complete documentation. But the reason I mentioned that is that not each, but many CRAN packages have something called a vignette, V-I-G-N-E-T-T-E, and these are really wonderful, and they also have task, what are they called, Joe? Task views and vignettes. So both of these together is a good way. For example, if I want to learn into get an understanding on a new area, I don't know much about it, but let's say you want to get better at text analysis. So there will be a task view just for text analysis in R, in CRAN. You go start reading that. In the task view, it will list a lot of packages that are useful, and then those packages may themselves have vignettes. In fact, dplyr has 5 vignettes, so you can really go deep into dplyr if you want, but that will be probably a good way for you to get familiar with. And then as you attend all of these talks, watch what people in GitHub are doing. There is a website/mailing list that I highly recommend called R Bloggers. It is r-bloggers.com. It's about close to 500 or so bloggers worldwide, and it's a curated site. So you get, I subscribe to the email version of it. I get 1 email a day where 5 or 6 posts show up on a daily basis. So they meter it so that it doesn't become too much or too less. And normally I don't have the time. I can't read all of them, but I do go through them. And if I find some package repeatedly being mentioned there, I'll start going to check it out. So there are many ways to find out about new packages. But since we're going to talk about data manipulation today, let's first understand, right, why this thing. There are many terms are also again used for data manipulation. I use data manipulation. Some people use data carpentry. Data munging is a term there. They all refer to the same thing. And this person here, DJ Patil, sort of is credited with having come up with the term data science when he and a colleague were in LinkedIn. So forgive me, but I'm going to read it along with you because this is very important. So he says, good data scientists understand in a deep way that the heavy lifting of cleanup and preparation is not something that gets in the way of solving the problem. It is the problem. So while all other talks here are talking about how many cool advanced statistical and machine learning techniques there are, data manipulation is something fundamental. You first have to cross this hurdle before you even can think about all of the other ones. And then they have a book on that, on how do you build data science teams. So broadly, and we can't cover all of them today, but what do people mean when they mean data manipulation? How do you do data munging, right? Sometimes, in fact, in real life, you'll almost always have missing values. When you have missing values, what can you do about it? That is one aspect of it. How do you summarize your data? So many different ways. You could group them by factors. You could aggregate the data that you have. You could create a histogram. You could create a table, which we'll look at today. You could subset, meaning if I have too many rows, if I have say 1 million rows, but I'm only interested in a particular one, that you could either get it all and munch it, or you can sort of take only the subset that is of interest to you, work on that, and this is something that we do at my workplace very typically. Very often we work on a subset of the data. If you think that your whole analysis works for this subset, then maybe you can run it on the full data set. So a much cleverer way to get 1/100th of the data if it is big, or at least 1/10th of it if your data is not so big. Do your full analysis, then come back when the data analysis is working, then you run it on the full data set. So subsetting data for many reasons is incredibly useful. If we have time, we could look at bucketing. Otherwise, I have the slides on a command called cut included. You could look at it when you look at the slides. Whereas data manipulation also includes rearranging or shaping. If you attended the keynote, the speaker talked about tall and skinny versus sort of squat and very, very wide. So both of these are different shapes of the same data set. He talked about transformation because it was a matrix, numbers you were dealing with, but that's what we mean by rearranging or shaping the data. There are different packages, and I would especially call out one called Reshape2, RESHAPE2, again written by Hadley Wickham, the same creator of dplyr and ggplot2, but that's an incredibly useful package for whenever you want to rearrange data. Finally, for those of you who come from an SQL or database background, you know how important it is to merge data sets. In fact, there is a belief that if you had one data set, you can only do subsetting and slicing, but when you start merging two or more data sets, new insights start to appear, which were not there obviously in any one data set. So how to do merging is an incredibly important aspect. If you guys are interested and if we have time, we could look at it. Otherwise, the command is just called merge. So depending on how it goes on the interest here, let's see how far we get through. Okay, but let's start with data quality itself, right? That's probably a reasonable place to start. What do we mean by it? As I said, real life data sets are never perfect. And so what can we do? So here is just to make sure, right? It's post lunch, it's 3 o'clock, I don't want you guys to fall asleep. So if there are missing values, what are some of the things that we could do? Shout it out, there are no right or wrong answers, but ignore them. Okay, that's one way to do it. But okay, let's talk about that. Ignoring is a good option if you have kind of data rich. If you have 1,000,000 rows, and if you have even 100,000 that are missing, you still have 900,000, you're okay. But many of us are not that lucky. Let's say this is a patient data, right? And if you do something like that, you may or may not want to ignore that. It depends. So, okay, ignoring is one option, reasonable. What else? I heard many. One is enough, yeah? Mute? Impute. Okay, can you elaborate? You can do imputation, right?
So basically replace the missing value with the average.
Yep.
Or
very standard one. Yeah. So you heard all of you heard what she said. We could always do data imputation. And a very reasonable one, though it has its own dangers also, is whenever it's missing, you could take that average. Say one cell in a column is missing, you can always take that average of the column and shove that value in there. It's one way to do it. Any other ways? Any other techniques for how to handle missing data or missing values? If this is time series, something that we always do is you could take the last few and you could put it with a moving average, and there are many other ways. It's a whole science in itself how to deal with missing values. What can we do? Maybe I'll wait because there's a slide coming on duplicate rows. Inconsistent dates. This is such a huge thing. Again, because it's only a short talk and I don't want to go deep into it, I just want to bring up saying that if you are working with any kind of data at all, especially if you're working with time series data, having dates or dealing with dates becomes incredibly important, and R is both, some people hate it and some people love it, but many packages have been written just to make your date manipulation easier. So we'll look at a few of them, but I just want to at least mention that you have a string, there is a command called as.date. That is enough for it to at least convert it to become a date format. And then I don't want to get into it here, but I just want you guys to note down that there is something called POSIX, capital POSIX. This happens to be a particular format. If you can get your date to be POSIX or POSIX LT, called long type, once you do that, a lot of mathematical operations on time become available to you. So you can sort of add dates. If you give 2 dates, it will tell you how many days are there in between, it will tell you how many hours are there in between. All of those things become possible. But a good sort of point here is that you first have to make your dates consistent. We have to do this again, where I happen to work, we deal with dates a lot, and this is sort of a big pre-processing that we do before we can even start doing the actual analysis. And then sometimes you will get impossible values. For example, there will be negative numbers for sales. Okay, and so it's not like it could have been fat fingering or something, so people got it wrong. but it could also have been that maybe there were returns and then they were put it in there with a negative number, and if that was the only thing that happened in that time period, you could see a negative number there. Outlier detection is again possible. Many people do that. You can just have to, based on that, you can see that. We'll look to see how, that's where subsetting comes in. Or you conditionally, you say that if this value falls, say below 0 or below certain things, you can just throw it out. Again, it depends on how data rich you are. Okay, again, before we get into proper data manipulation, let's understand, if you're going to use R, there are 4 keywords, and I don't think this can be used interchangeably, but it is good for us to know all of them. 2 of them we use a lot and 2 not so often. So first, as soon as you read anything into R, if it is missing, as we already talked about, R puts this NA there, right? I don't exactly know, but let's call it not available. It says that this is missing. By the way, anything with a hash and any text after the hash mark is a comment in R. So it just says that, hey, this value is missing, which should not be confused with the next one called null. Null, on the other hand, means that some data is undefined. Okay, these are not the same. NA means that there may have been some data there, but null means that it is not defined. There is one other use, special case use for null. Joe talked about a lot of functions, how to write functions, and functions will return. Sometimes the function will either have an error or it doesn't know what to return. In those cases, null is typically, by convention, people will just return null. Therefore, when you're calling a function, if you're calling your own user-defined function, you can first check. If the return value is not null, that means that you've got something decent to work with, you can go on. So that's another use for this keyword called null. Then inf, it's there. If you're working with a lot of math, of course you need it, but it just stands for infinity. And then though on a day-to-day regular work, I don't end up using this that often, but you just have to trap for it and make sure that you don't get that. Again, not to be infinite, inf is very different from NaN, which is not a number. Again, in real life, I have never had to use this, but I very often would use the check to make sure that something is not a number. So there's a command called is NaN. But for example, infinity by infinity is not another infinity, or maybe we don't know that because sizes of infinity come into play here. Therefore, R will return a NaN for that. Okay, some details on this. I don't think that's important for this discussion. So let's kind of start getting our feet wet a little bit. Let's go into how to deal with unavailable values. So here, let me put it all up here. Joe did talk about this, but I want to spend a few more minutes on, maybe 2 minutes on this thing called is.na. Very easy to use command. It will just, is.na will give you 2 answers, true or false. Let's take the first one, a particular variable. Is it NA? And if it says yes, that means that is NA of NA will give you an NA. So what you normally do is you check for it. If it is not an NA, that means you're actually dealing with a number or something that is not NA, you can proceed. What is interesting about R is that you can deal with is NA for an entire vector. You don't have to go one by one, or you don't have to write a loop like we would do in many typical languages, right? Because it's vectorized, we can say is this whole vector NA, and out is going to come a result which will give you a whole series of trues and falses. Okay? So let's take an example there. In this case, X is a vector of 3, NA, 4, NA, NA. How many elements in X? How many elements are there? In X, there are 5. X is a vector of length 5. It has only 2 useful values, 3 and 4, and there are a bunch of NAs in there. So you could do one thing, like I said, you could run it on a particular variable. In R, you index each element by its number. So the first one, unlike in Python, it is 1 offset. So the first value, 3 in this case, you would write X square bracket 1 would be the first value. So I'm asking here in the next line, is NA of X of 2? We're asking, is the second value in this vector called X, is it an NA? And it has to tell, it will come back with a true, which means it is yes. Why? Because there it is an NA. You can now run is.na on the whole vector. And then it gives you false, true, true. Because only 3 and 4 give you a false because they are not NAs. But very often we want the reverse of that. We want to catch all the NAs. So you should say not, which is the exclamation mark, which is whereas we are reversing it, not of is NA of X will give you true, false, false. Everyone got that? Any questions on what we are doing? No? We good? Okay. Now you can there is actually a data set called air quality that also comes with R, and now I'm running it on this air quality $ozone. If you had the computer here, we could do it together, then it would give you, if I say not of is quality of air quality $ozone. What is dollar again? In R, you have a data frame. Think of it as a rows and columns, right? So air quality is the name of the data frame. It's the name of this matrix. It's the name of the big rectangle of data that I have. In that, I can refer to any column I want by its name, but I have to put a $. Before that. So there is one column in this data frame called ozone. So I'm saying air quality $ozone, and then it will tell me whether there are NAs or not. So let's try that live and see if it will work here. Again, I also have to turn back because it's not coming on my screen. I have to find my cursor. Apologize for that. I don't know how to find my cursor here.
On the top.
Yep. So air quality, you just type it, because I told you it's a built-in data structure. If you just hit enter, it shows you everything that is there. What you would do is you type dim, which is dimension of air quality. It will tell you how many rows and columns there are. So if you guys can read there, it says there are 153 rows and 6 columns. But what we are interested in is seeing is .NA of air quality $ozone. Ozone happens to be one of the columns. Before that, let me say that you can say what are the names inside air quality, and that will tell you each column name. So you see that the first column is called ozone, the second one is solar radiation, solar.r. There is a column called wind, temperature, month and day. So there are 6 columns in this, but we are interested in the one called air quality $ozone. And then if I hit an is NA on that, before I do that command, I want to make sure everybody's paying attention here. How many values will I get back if I type is NA of air quality $ozone? 153, that's right. One for each row, and it will tell me if that is a true or a false. True means it is fine. False means that it was not an NA value. True means that it is an NA value. So I hit there.
Case sensitive? Ozone?
Ozone, yes, it is case sensitive.
Ozone.
Yes, R is case sensitive, thank you. There it is. And actually I want you to pay attention to something else also. R has conveniently given us some numbering there in the screen. You can see that 111, and so the last 3 values are 151, 152 and 153. They're all false. But you can see there are a bunch of trues in there if you're able to read it. All those rows are the values where NA was there. We didn't have a real number in there. So for whatever reason, if you're going to do some mathematical, let's say we're going to calculate the mean ozone level for all these data points, first we have to take care of this. Sometimes your function can actually knows to throw it out, otherwise it may trip and give you an error, therefore you have to take care of it. That's how is NA works. I won't spend more time on that. I mean, you can create a true false vector and then you can go through this, but all this code is available and you can look at it. I'll put it on the GitHub also if need be. Any questions on is NA? That's just a starting point, so it was easy enough. Again, I told you we want to deal with, very often sometimes we have to deal with duplicate rows. So which rows are duplicated? Again, R makes it really, really easy for us. Otherwise, if you think about it, we have to write sort of loops where for each row, we have to do, first you keep it in mind. First time you say it, you keep it, and then next time you have to compare it with the previous row and say, is it the same or not? And if it is not the same, you keep that also, and you have to keep track of it, and you have to do n-squared operations before you can sort of identify how many of these rows are duplicated. We don't need to worry about it because R has also already done it for us. So we'll just run this command called duplicated on a whole data frame. What it does, it's important to understand what the results are going to be. The first time it finds a row, it says it is not duplicated. But after that, every subsequent occurrence of that row will be a true for duplicated. So the duplicated also, just like SNA, is going to give you false true. But the very first time it saw the row, it is not. So it will give you a false. After that, it's going to get true, 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 true each time it sees that row again. Let's try that on this data set that I mentioned called iris. So first, again, let's look at iris. It has all of these 150 rows and 5 columns, but we're going to try duplicated of iris. And if you notice here, In the 143rd, I knew this, I've done this before, so the 143rd row is duplicated. So it was either the two flowers had exactly the same measurements in all, or maybe one flower somehow got repeated. So you can decide, you can leave it in there if it's a big data that you don't care about duplicated ones, but for whatever reason, if you want, you can sort of eliminate that and work with the remaining points. It depends on what you want, but I just wanted us to know how we would find a duplicated row. Couple of other quick options in data manipulation. After you have read in any file you have, in R, there are different formats. For our purposes, we just want to know whether it's number, it's an integer, is it a string. String, we go by calling it character here. So these are called coercions. Even if your column is of some other type, just want to mention that you could do as.numeric of and force a particular vector into it. Then any number in there that it finds, it would make it. So if you had a string in which you have written the number 1.3, but if you force as.numeric on that string, that will become a number. So this is a way to sort of, for those of you who use C or any other language, you know how to do that. Similarly, if it has some other type, you're just making it a character. Why do we need to do this? Because certain functions that you're going to call, they can only handle some types of input. So if you have a function that handles numbers or numeric values, you may not be able to pass a date into it or a character into it. Therefore, you do this as numeric, you convert it. After that, it's good. You can now call that function. Very, very useful if you want to do basic data manipulation. Now let's get into subsetting, summarization, and aggregation. Okay.
A quick question.
Yeah.
So, is that a package, object?
No, this.
As, like when you say that. Like,
yeah. As.numeric is the command itself. Okay. And I should also have mentioned that R is confusing to a lot of people who come from, let's say, an object-oriented or some other language where the dot means it's a method, right? Inheritance is what we talk about here. But here, ideally, probably we should have called this as_numeric or something, but this goes back long before. So as.numeric is one command. It is not as if as is something separate and we attach the numeric to it. So as numeric and as character are two commands that come with base R itself. Okay. And I think to your point, if you want to find out, there are commands to find out all the commands that are there in a particular package. So for base R itself, if you find out, there are over 1,000 commands that come with just base R. It's very difficult. There are some esoteric commands even in very basic R, base R, but these are the more well-known ones that we start using. Any other questions before we go to subsetting? Is the level okay for you folks? Yeah? Okay. Before we get into subsets, let's understand also something called, we saw what numeric was. We have seen dates just a little bit. We saw characters. But there is this thing called factors. And let's see what that is. So if you know statistics, then you know what are categorical variables. Basically variables that or a row, your record can fall into one of many categories. So for example, gender is a very classical, a prototypical example of a categorical variable. Typically you would fall, if you're classifying people, you could just simplistically classify them as they're either male or female. That would be one example. You could say that a meal served in some conference or wherever you're going, saying that breakfast, lunch, or dinner, these are three categorical. There's one variable called meal which takes on these three values. These values are called levels. And one more example, you can say hair color, whether it's blonde, brown, brunette, or redhead. All of these are factors. So the important point to make here is that in a categorical variable, there's no intrinsic ordering. We are not saying that breakfast is greater than or less than lunch or dinner. We don't make any such claims. We just show you that, we just say that there are these three factors. And why is this again important? When we are doing analysis, we may want to study only some particular type. Maybe we want to study only the males, only the females. Maybe we want to do comparison of males versus females. We could do the same thing for breakfast, lunch, dinner, and so on. So that's where factors come in. And these factors have, I already mentioned, they have these levels. And so, again, maybe I can show this to you when I go back to the code. See, there's a command called class which will tell me what it is. Initially, the species would have been a character string, but if let me show you both of these, and then you can see how levels work in R. So let me go back to my code, and then there's a command, like I said, class of, I have to remember what it was, class of species. Iris is the data frame. I'm going to find its class. And if I say species and I hit enter, it's telling me that hey, that is a factor. And let's compare that with, let's see what the values 1 through 5 are for, so this is one vector now, and let's say that I want to look only at the first 10 numbers, okay? So within square brackets I put 1 through 10, which means that iris.species is a vector of 150 numbers there. We know there are 50 flowers each of 3 species. Let's say we want to look at the species of the first 10. It will list them. They all happen to be of only one species called Setosa. But you notice that the important point I want to make here is that you see it says that the levels, there are 3 levels in species. So even though it only printed Setosa, it says that the other levels that happen to be in this data set are versicolor and virginica. Okay, so that's how factors work. Why? This will only work because class of iris dollar species was a factor. It's like there are a total of 3, in which case we are looking at only 1. I won't cover empty cars now, but the same thing, you can do that. Let's look at the subset function, probably my most, one of the most favorite and very often used function for data manipulation, and its usage is also very, very simple, intuitive. It's a sturdy function, will not give you any errors. So let's take a look at it. It's as simple as it gets. You want to subset a data frame, which is the data that you have, by some condition. Okay, that's all. It just needs 2 things. You need to tell it what the data frame is and what the condition are. So I could create a data frame called small iris, which is a subset of my iris, where what am I doing? What is the condition there? I'm looking for a particular column called sepal.length, and I just want it to be greater than the number 7. So it may have all sorts of values. It is just going to get these, and then it will print it out. So we could even try that here. So first, maybe we want to understand a range command. So let's look at range to say, hey, what values do sepal.length take? You see, RStudio is nice enough that it told me there were two columns that had started with capital S. And then when I say the range, you guys see that the numbers go from 4.3 to 7.9. But let's say I want only those big ones. I want anything bigger than 7. So I would say subset iris, and then you will say sepal. No, here I have to type it. Sepal dot length is greater than 7. And then if you do that, it just gave me these few. It picked it up, and they all happen to be this particular species. So maybe that's an interesting thing. The species has, I guess, longer sepal lengths, and then they just show that to me. That's how it works. Question?
The expression that's being passed to the function, is that being passed as a string?
Yeah, that's a good question. You're talking about inside the subset?
Yeah. So where it says sepal.length is greater than 7, is that being interpreted by the function as a string?
Not as a string. So I think I have it in here next. I'll tell you. I want you to pay attention to, let's see. As you correctly point out, I did not have to say iris $sepal.length. I could have done that. So only subset function has a special characteristic because it is getting a data frame. There is a context. It understands the context. It says that now let's pay attention to that command. Subset iris. So it says I'm probably going to get some function. This condition is going to relate to iris, and therefore it looks and sees if there are columns called sepal.length. So even though it was passed as a string, you're absolutely right. It was passed as a full string actually. Sepal.length greater than 7 was a string. But inside that function, whoever wrote that subset function, they were very clever. They're able to parse it and evaluate, and they understand that it is a condition, and they know that that sepal.length refers to a column in the data frame. So it's much cleaner than reading all these dollars and all that. So small iris says subset iris with sepal length greater than 7. It's an important point to remember. Again, in the next command, even though I'm not doing it here in the interest of time, subset movies, comma, MPAA is equal to within quotes R. Why are we putting 2 equal to's there? Because we are not assigning. Whenever the condition, as you know in many other languages, the same idea holds. If you have to say is it equal to, when you're testing it for a condition, you have to give 2 equal to's in R, and then because it's a string, you've got to put that R inside. And so what this will do, it will only show you all the R-rated movies. So that's essentially what we have subsetted it here. After you do any kind of a subset, it's always a good idea to make sure that your condition did, if after doing subsetting, you are ending up again with the same number of rows as you had before, it's either that, it basically means that condition did not do anything. So a good idea, as soon as you finish a subset command, is to make sure just look at the dimension. In this case, I printed it out, so I saw that there were only about 10 or 12 of those flowers that had that condition. Otherwise, you may want to do that, just a good practice. Any questions on subset? Okay, good. Let's do one more and then I'll breeze through dplyr after this. So table is a very, very useful command. What does it do? It counts the number of observation in each level of a factor. Incredibly useful command, maybe even easier to use because let's say it takes only one argument, table of a particular vector. So it would look like this. Let's go through it together and let's say I don't type it. Let's say table of iris $species. What do you think it will do? Maybe the first one I have to show you, that's not a fair question, and then after that you will be able to answer. Yes, it is counting, it's going to count, it's doing a quick histogram. It's saying for each species, we already know that there are 3 species, it's saying how many flowers are there of the first species, how many of the second species, how many of the third species. All that done in one command. The table is also in the base package, so table of, what did we say, iris $species. Okay, if you do that, it nicely tells you that there is setosa 50, versicolor 50, and virginica 50. That was an easy enough way to do that. So let's see, table of empty cars $gear. I already mentioned to you that there is another data frame called empty cars that comes with R. So and then $gear. So these gears can take on multiple values. So let's see that. It is saying that this data set has 32 points, 32 different cars, automobiles. And all automobiles have 3, 4 or 5 gears. The table command is telling us that in this data set, it's kind of skewed. It is not as if there are 10 of each. There are 15 automobiles with the 3 gears, 12 of them have 4 gears, and only 5 have 5 gears. So why is this important? For many, many reasons. Also, as you are coming up with conclusions, it's also good to know that, hey, maybe we can't make as strong a statement about 5-geared vehicles because we have fewer data points in that. So these are some of the reasons why you would do the table command. It's essentially a histogram that is creating for you and then showing it numerically. You could do something cleverer also or interesting. You can put together 2, so table.cylinder does the same thing. Here, look at this table of, I can say gears and cylinder. Okay, so table can also take 2 arguments. It can take more arguments also. I forgot to mention this during subset. It's very useful because subset command also doesn't have to take only one condition. It can take multiple conditions, which is where it becomes really interesting. And you can stitch all these conditions together with either different AND or OR values. That is when subset becomes really powerful. This table command, same thing. So let's take a look at this one. Let me see if I can type that. So we are saying, hey, show me a table of empty cars of how many gears there are and also by how many cylinders there are. Okay, so I'm going to make what would become, we would hope, there's an S in gears. There it is. Okay. So in R, everything is always row followed by columns. That's at least how I remember it. So row followed by columns. So the rows have the 3 gears there, and the columns we already saw, we know there are 3, 4 and 5 geared vehicles. We knew that. In fact, if you add all these rows, you will get the numbers we got in the top, which is 15, 12 and 5. Look at the bottom row, 2, 1, 2, you add it up, it is 5. But it has further subdivided it by telling us how many 4-cylinder vehicles are there, how many 6-cylinder vehicles are there, and how many 8-cylinder vehicles are there. With one R command, which is fairly easy to use right there, that's all. It was not very complicated at all. That's why I call this basic data manipulation. We are not doing anything fancy, and yet we are able to get this. Of course, empty cars is a very small data set, so we could do it in so many different ways. But imagine you are at work or when you are doing data manipulation, somebody gives you a huge data set. First, you want to do what people would call data exploration. You're just kicking the tires and seeing what is in your data set. Commands like this very quickly give you a feel for what is going on. You do a few subsets, you do a few tables, you already know a lot more about the data than even probably the person who gave you that data set. So these are all very beginning steps to doing what data scientists do. This is what we do.
Excuse me?
Yeah.
If we put more number of columns in the table command,
how is it going to do? Let's take a look at it. Of course, it cannot show more than 2 dimensions. So that's a very, very good question. She's asking, hey, what if there were more than And then so what it will do is it's doing this pagination. You have to visualize a 3 dimensions where there is a 2D table followed by another 2D table followed by another 2D table. So think of it as layers, and it's just going to show us those layers one after another. So let's try one. Empty cars dollar. There happens to be another variable called AM, which says whether it's automatic or manual car. And so now when you hit that, you see that it's saying is equal to 0 is all the manual. I don't know which one is manual versus which one is, but it's then giving you that's all it did. More than 3 also you can use it, but now it's getting confusing and all of that. So you may have to do some other techniques, but that's kind of how you do. Okay. So before we jump into dplyr in another 5 minutes or so, I just want to say that hey, there are many commands here called is.na. We saw that you could do na.rm. rm is for remove. You can remove the na values. Is NaN, is NULL. They all do similar things. We talked about how we use table to get frequencies. We said that we could take a data frame, we would subset it, and we would say that any variable is equal to some value. Some condition you come up with, you subset it. These are the very building blocks of data manipulation, if you will. Then let's quickly go through dplyr. In the interest of time, I just want to show you at least, there are 2 or 3 slides. Even if you understand how dplyr works, we don't even have to look at the code. The code is made available to you, where I gave you the link to, which I'll show you again. But this person here is Hadley Wickham. He's created many packages that are incredibly popular in R, including ggplot2. He's also the creator of plyr, and this particular reshape2 is his. Many others as well. But dplyr is a very new package that has actually been introduced, perhaps towards the end of last year. Started taking off in 2014. So this is very fresh, real good stuff. And the D there stands for data frames. It only works with data frames. But again, why would we use dplyr? Because it is sort of easy once you understand the basics. It's really fast. R has one reputation as being slow, and it is definitely slower when compared to Spark, as we saw. It's also slow compared to Python. But to kind of combat it, or to come up with those who are using R, there are many reasons to use R, but this is one way where they make it very fast. If you're coming from the SQL world, I strongly recommend that you look at dplyr, because you will take to it very intuitively. The syntax is very natural. It's intended to be like a recipe, or as he says, you code the way you think. So for us to, even if you don't understand anything else about dplyr, if you understand this paradigm, this idiom, it's very good. It's called SAC. Which stands for Split-Apply-Combine. Various forms of this is essentially what MapReduce also does. But we're going to take a data set, we're going to take a big data set, we're going to split it. After that, we're going to apply, after we split, we'll get many groups. To each group, we'll apply some function, and then you combine it. Essentially, MapReduce also works in the same paradigm. You split, then you apply, you map it, and after you do something, you reduce it. That's a reduce phase. In this case, it's not a big data frame by any means, but just for example, there are 6 rows here, A, B, and C. You split them by the X column, so all the A's went together, B's and C's went together. Then you took the mean, that is the apply part, SA part, and then when you combine, you sort of bring their averages. That number should have been a 3 there, it's just a typo, but that's what Split-Apply-Combine does. And this paradigm is what dplyr is going to help us do. So I'll skip through the pretty, it has a few other features. It makes your data frames look pretty. It gives you summary of that, but we don't have to spend time on that. By the way, this, like I said, the pipe operator was actually introduced on Jan 1st of this year, so this is really fresh. Maybe I should stop. And if you're going to understand dplyr, a big hurdle to using dplyr is this operator called the pipe operator. Percentage greater than percentage. But don't get confused by it. Just read it as and or then and then. And then what do you do? And then what do you do? If you use, any of you here use Unix, you know the pipe command where we take one, you see ls, and then you do a wc on that to do word count. You're just piping it one after another. That's exactly what is going on in dplyr. So again, because we're running short of time, but maybe this, I'll at least show you what the idea here is. You take the number, you pipe it to a function square root, whatever results come, you can again take that results, you pipe it again to another function called round. Out will come now a rounded value of 31.622, which in this case it rounds up to, let's say, 32. That's how pipe works, okay? You literally are piping it together one after another. If you know this much, you'll be able to use. And now you can see how the pipe one works, right, in dplyr. It's going to take the data, pour it to the next container. From there, you do something, you pour it to the next container. So this is sort of my we are showing you how, and then in the end you get your results. Sort of data sort of flows through this. If you have this analogy of data as a liquid or a fluid, it's kind of just going to flow through. And there are mainly dplyr, you need to know 5 things. We already saw them in some sense, but filter, which is a subsetting, you can filter rows, you will arrange, which is a way to sort them, reorder them, you can select columns, and then mutate is when you can create new columns, and summarize, which is group by. So let me see if I can leave you guys with this one. This may be my very last slide where I don't have time to show the code, but it's all available in the link I gave you. So how do you remember filter? It's confusing, but you only need to remember these 5 things. If you remember these 5 things in dplyr, you'll be good. You'll be able to do it. So you need to filter rows. So what are we saying? The R is the common one there. You take a lot of rows, and after that you just keep applying your conditions, just as we did with subset. You will get your rows filtered. You could do select column types. So among many columns that I have, maybe based on some conditions, you go and say which columns I want, then it's going to pull those as dark greens down. The other columns you don't care about. Very typical operation. Usually you will have like a very wide data set. You're only interested in 3 or 4 columns. You don't want to carry around that baggage. Throw out all that junk. Select the columns you want, and then you operate on it. Select is a very powerful command in dplyr. You can sort of look for contains, and you can do many things inside select. Some examples are there later on in the slides. I won't be able to go through them today. Arrange, like I said, you're arranging rows. It's essentially sorting by descending, ascending order. If you've done it in Excel, then you know that you don't have to sort by only one column. You can sort by this, and then by that, and then by that. You can keep chaining it, and you can do ascending, descending for many columns. So it's a very useful command, very easy to read also. Then that's the last one, mutate. Probably it's actually in base R also, but may not be that intuitive. But you mutate something into something new. Like a mutation happens. A column that did not exist before now exists. That's the genesis of the word mutate. You can take any 2 or 3 columns in your data frame and you create a new mutation of it. Yeah?
The main purpose of mutation?
Yeah.
What's the main purpose?
To create new columns. You may want to calculate an average. You have 2 ones, you can do A by B, you can do many other things. And then finally group by, which as the name says, it's to summarize by groups. So you have most of those. We saw that the whole SAC. I think we're coming up to 10 minutes, so maybe I'll stop, answer any 1 or 2 questions. The code for all of this, I don't have time to cover here, but as you can see here, I show you examples of filter, and then in the next slide, I show you examples of select. There are so many different things, and then I show you how to arrange. Because I said, right, many people here were new to R, I didn't want to, that's why I spent more time on the earlier part of the simpler one. Normally I wanted to spend more time on dplyr, and here is an example of mutate. So maybe I created a new column here called aspect ratio, which is my petal width divided by petal length. So your data frame now has an extra column that it did not have before, and so on. And then you can group by rating, you can group by year. So now you're quickly able to group it and then do a lot of operations on that, summarize and get one level. You can put it all together. As an example, all this code is runnable code, so just go home and try it. You can then, the results of that can be put to plot. But I'm rushing through so that I can leave you guys with this one. Again, all these slides are available if you go to group.gl / those 5 or 6 letters. And if you want, I can put the code on GitHub and you can just try running it. Like anything else, here are some references. But if you practice, that's the only way to get good at data manipulation. I'll stay here for a few more minutes, but if you have any questions that you want to ask. You want to go back to the link?
Yes. Thank you.
Sure. Yeah.
So is working with R, how is working with R different than, say, MATLAB?
Than MATLAB? Actually, a lot of my colleagues, and I have used MATLAB when I was in grad school, so I'm probably biased because I use R a lot, but I find it easier. It's very similar though. I can tell you that those of my colleagues who have used MATLAB take to R much easily. I don't know how else to say how is it different, but yeah.
Does R have capability to handle the real-time streaming?
Does R have capability to handle real-time streaming? So, I'm going to defer to Joe from Revo R, who is sort of much more into that. But Joe, do you want to take a shot at this one?
Sure.
Does R have capability to handle real-time streaming?
Well, people use the standard loop streaming, and people use R with that. So, yes.
That said, I can tell you that in my work we use R mostly for batch, And even the Twitter analysis that gets done, we're not doing it live as the tweets come in, though people have tried. Hadoop streaming is there for Python, which makes it easy. So if you really are interested in streaming and that's your main use case, perhaps R is not your first choice. You don't want to oversell this. But for a lot of us, it's very easy to come up to speed. You can, as you saw, you can come up to speed much faster using R than perhaps a setup. Python comes closer, but for you to do get going with Java or Scala may take a little longer. With R, you can be that much faster. But again, it's a biased view. Yeah.
Can R go to production if they want to go to production levels? Server deployment?
Yes, it can. There are people have been working on this. I mean, it is again not your first choice, but a lot of work has been done by Joe's company and many others also. There's something called RServe that you want to look at. And then there are many other connections from R to say Java or R to Python. There are different ways to where in my workplace we embed R code inside say Java, and then for your whole framework can be Java. Those of us who are comfortable with R continue working on R, they put a wrapper and they make it work. So there are different ways to approach it.
Thank you.
Yeah. Any other questions? Thank you for your time. Thank you so much.